Hey all, this is lesson 6.2. Matrix algebra is what it's called in the textbook, but I'm just going to call it matrix operations. That's pretty much all we're doing in lesson 6.2 is adding or subtracting two matrices and multiplying matrices, which is just matrix operations. So we'll start with add or subtract two matrices. Very, very easy to do. One thing though that you have to be sure of, in order to add or subtract matrices, each matrix must be exactly the same size. So you can add a 2 by 2 matrix to another 2 by 2 matrix, or a 3 by 3 to a 3 by 3, or a 2 by 4 to a 2 by 4, but the dimensions have to be exactly the same in order to add or subtract two matrices. So as an example here, I've got a 2 by 3 because it has 2 rows and 3 columns. And I've got another 2 by 3. So since these dimensions are exactly the same, I can add these two together. And the result is going to be another 2 by 3 matrix. And each entry in the matrix is going to be a result of adding individual entries. So this entry plus that entry, 3 plus 0 is 3. And then this entry plus this entry, 2 plus negative 1, for example, is 1. And then 1 plus negative 11, negative 10. 8 plus 20 is 28. Negative 4 plus 9 is 5. And then negative 2 plus 4 is 2. And subtraction works the exact same way as addition. You've got to make sure each matrix is the same size, and you subtract entries that are in the same spot. Now, multiplication is going to be broken down into two different topics here. There's a certain type of multiplication called scalar multiplication, and this is where you're not actually multiplying two matrices together. You're actually just multiplying a matrix by a number. A scalar is what it's called. A scalar is a non-zero constant. So for example, if we have matrix A here, a 2 by 2 matrix, I'm not going to multiply it with another matrix entirely. I'm going to multiply matrix A by 3. 3 would be considered the scalar here. So 3 times A would be 3 times the matrix. And as I'm sure you've probably guessed, you just multiply each entry inside the matrix by whatever the scalar is. So every entry there is going to be increased by a factor of 3. So 6 times 3 is 18. Negative 2 times 3 is negative 6. 3 times 4 is 12. And 3 times 11 is 33. That's called scalar multiplication. And quite often, especially in your homework, they're going to mix scalar multiplication with addition or subtraction. So an example here, got 3 matrices, A, B, and C. So for part A, we're going to find 2 times A minus 3 times B. So 2 times A minus 3 times B So first thing we want to double check is sometimes the answer here is not possible because we can't add or subtract matrices if they're different sizes. So just want to double check. This one's a 2 by 2, this one here is a 2 by 2, so they're the same size. So 2 times A is going to be 6 2, 8, 0, and then subtract 3 times b, we're going to have, if I multiply that 3 in there, I'm going to have 6, negative 15, negative 3, and 24. So we'll subtract entries in the same spot now. For example, this first entry here, subtract that first entry there. You gotta make sure you're subtracting or adding entries that are in the same spot. So 6 minus 6 is 0. And then 2 minus negative 15, minus a negative, remember, becomes positive. So that's 2 plus 15, which is 17. Then we have 8, subtract negative 3. Subtract negative 3 means plus 3, so 8 plus 3 is 11. And then we have 0 minus 24. It's negative 24. Part B, 2 times A plus 2 times C This one's not possible because this is a 2 by 2 and this one here is a 3 by 2. Since the dimensions don't match, I'm not going to be able to add a plus c or 2a plus 2c. So you would, for this one, say not possible. Okay, now we're to the other part of multiplying matrices where we're actually going to multiply two matrices together. So in order to multiply two matrices, it's not a matter of both matrices being the same size. They actually don't need to match exactly. But in order to multiply, for example, matrix A to matrix B, the number of rows in matrix B must equal the number of columns in matrix A. For example, if matrix A is, let's say it's a 3 by 2, and matrix B is a 2 by 2. Now obviously they're not the same size, but the number of rows, because remember we always measure a matrix rows and then columns, so the number of rows in matrix B has to equal the number of columns in matrix A. So since these two numbers are the same, A times B is possible, and I'll show you here in a second how to find that. Now a couple of things to keep in mind. Matrix multiplication is a little bit different than traditional multiplication of numbers, where it's called the commutative property. 3 times 2 is the same as 2 times 3. They're both 6. That's called the commutative property. That does not apply to matrix multiplication. This A times B is not the same as B times A. You can't commute multiplication when we're dealing with matrices. And case in point, with this example here, A times B is possible, but let's take a look at B times A. And here's a maybe an easier way to lay this out, to think about it. I've seen a lot of students do this. A times B, and then lay it out this way: a 3 by 2 and then a 2 by 2. If these inner dimensions here are the same, then the matrices can be multiplied. Flipping this around though, B times A. B, remember, was a 3 by 2. Actually, sorry, B was a 2 by 2. And A is a 3 by 2. So B times A, if you look here, these numbers aren't the same. not possible. Whereas here, A times B is possible. So you always want to check the dimensions. The number of rows of the second matrix has to equal the number of columns of the first matrix. Now, that's what I have written out here. Matrix A is a 2 by 3. Matrix B is a 3 by 2. So this tells us it is possible to multiply A times B. That's what these inside numbers here tell us. Now, these outer two numbers, these don't need to match necessarily. What those outside numbers tell us, though, they're also important. They tell us the dimensions of A times B. If A is multiplied by B, it will result in a 2 by 2 matrix. That's what this number and this number tell us. Once you've determined using these numbers here, once you've determined that the multiplication is possible, then these numbers will tell you the size of the matrix that results from multiplying those two matrices. So if A is multiplied by B, it's going to result in a 2 by 2 matrix. And here's what it looks like. So I've got A times B, and I've already checked that it's possible. We have a 2 by 3 and a 3 by 2. The inside numbers match, so it's possible. And then these outside numbers tell me I'm going to get a 2 by 2 matrix. So I've drawn a 2 by 2 matrix here, and I've purposely made it a little bit larger. A 2 by 2 matrix has 4 entries. Here's row 1, column 1, row 2, column 1, row 1, column 2, and row 2, column 2. There's 4 entries there. Now, this process doesn't seem intuitive, or it's not going to seem intuitive. Matrix multiplication was developed to satisfy a specific purpose. So you're going to watch this process and think, well, this doesn't seem like it's making a lot of sense how it was developed. So if you need to pause, go back, rewind, and we'll do a couple of examples here. But like Gaussian elimination, there's a few steps, and you've just got to be very slow and careful so that you don't rush through it to make simple mistakes. So this entry, for example, right here is row 1, column 1. So to find the entry that goes here, I have to use row 1 from the first matrix and column 1 from the second matrix, and form what's called a linear combination. Linear combination is a combination of multiplication and addition. So I've got 3 entries here, and I've got 3 entries here in row 1 and column 1. So what happens is I combine those entries by multiplying and adding. So these 2 entries multiply, and then I add that to these 2 entries which multiply. So 3 times 7 is 21, and then I add that to these 2 entries which multiply, 24. So that entry there is going to be negative 15 plus 21 plus 24. And then the process just continues depending on where you are. So this entry, for example, right here, this is row 2, but it's still column 1. So now I need to use row 2, and I'm still going to use, so I'm using row 2 from the first matrix and column 1 from the second matrix. So I'm going to go across the row and down the column. This entry and this entry again are going to multiply. So 0 times 15 is 0. Then I move across this row and down the column. So I'm going to have 4 and 7, which are going to multiply. It makes 28, so I'm going to add that. So add 28. And then I move across the row to 10. So I've got 10 here and 3 here, so that makes 30. 10 times 3 is 30, so I'm going to add 30. Now I'm going to move over here. This entry is row 1, but now it's column 2. Row 1, column 2. So I need to use row 1. But now I need to use column 2 over here. So I'm going to use row 1, but column 2. And again, form a linear combination. So row 1, column 2, the first entry is there, is -1 times 2, which is -2. I'm going to add that, and I have to move over here. The second entry of row 1 and the second entry of column 2 is 3 times 0, which is 0, so I add 0. And then I move over the third entry of row 1, and the third entry of column 2 is 8 times -1, which is -8. And finally, this one here, that's row 2, column 2. So now I need row 2, and I still need column 2. So now I take the first entry in row 2 and the first entry in column 2. That's 0 times 2, which is 0. Now I need the second entry of row 2 and the second entry of column 2. 4 times 0 is 0. And then I need the third entry of row 2 and the third entry of column 2. Multiply that to get -10. So I'm going to add -10. Now bringing this all back together, let's see, this entry right here, -2 plus -8, that's -10. This one right here, 0 plus 0 plus -10, that's another -10. This entry right here, that's 30 plus 20, that's 58. And then this one here, -15 plus 21, that's 6. And then 6 plus 24 is 30. And this was A times B. So like I said, it's nothing significant really. I mean, it's a lot of steps, but truly it's just adding and multiplying numbers together in a certain order. So you just need to get used to that certain order. But truly it's just adding and multiplying numbers together in the right order. So I have another one here. A times B. So let's just double check. A is a 2 by 2. And B is 2 rows and 4 columns. So I'm going to call that a 2 by 4. So we check to see if it's even possible. The number of rows of the second matrix is equal to the number of columns of the first matrix, so it's possible. And then it's going to result in a 2 by 4 matrix. So 1084 multiplied by 2, 6, negative 1, negative 4, 3, 3. It's going to result in a 2 by 4 matrix. Like that. And the nice thing, if you want to say nice, the cool thing about matrix multiplication is you can start anywhere. This entry, for example, is row 2, column 4. So you just need to go to the appropriate row and column. So row 2 and column 4, and you take the first entry, 0 times 7 is 0, and then you take the second entry, and the second entry, 4 times 8 is 32. And I'm just to illustrate my point, I'm just going to skip around. This entry is row 1, but column 2, so I need row 1 and column 2. So I take the first entry in row 1 and the first entry in column 2. 1 times negative 1 is negative 1. Now I take the second entry of row 1 and the second entry of column 2. 8 times negative 4 is negative 32. Let's see, where do we want to go next? Let's go to this entry right here. So that's row 2, column 3. So I need row 2 here, and I need column 3 there. So I need the first entry of row 2, and I'm going to multiply that with the first entry of column 3. 0 times 3 is 0. Now I need the second entry of row 2 and the second entry there in column 3. 4 times 3 is 12. And then it proceeds the same. So let's go to row 1, column 1 right here. Row 1, column 1. First entry of row 1, first entry of column 1. 1 times 2 is 2. Now I need the second entry of row 1 and the second entry of column 1. 8 times 6 is 48. Okay, let's skip over to here now. This is row 1 and column 4. So I need row 1 and column 4 right there. So the first entry of row 1 and the first entry of column 4, 1 times 7 is 7. And then I need the second entry of row 1 and the second entry of column 4. 8 times 8 is 64. Okay, let's do that one there. That's row 2, column 1. So I need row 2, column 1. So the first entry in row 2 and the first entry of column 1, 0 times 2 is 0. Now I need the second entry of row 2 and the second entry of column 1. 4 times 6 is 24. What are we missing? Okay, this entry right here is row 1, column 3. Row 1, column 3. Okay, so I need row 1, column 3. First entry of row 1, first entry of column 3. 1 times 3 is 3. Now we do the second entry of row 1 and the second entry there of column 3. 8 times 3 is 24. And last but not least, this entry right here is row 2, column 2. So I need row 2, column 2 right there. First entry of row 2 and the first entry of column 2. 0 times -1 is 0. And then the second entry of row 2 times the second entry of column 2. 4 times -4 is -16. So, after much trial and tribulation, let's see what we got here. 50, -33, 27, 64 plus 7, 71, 24, -16, 12, and 32. And this is A times B. Here it's asking us to find B times A. B is a 2 by 4, and A is a 2 by 2. So looking at that, we would say not possible. So that is matrix multiplication. Like I said, with practice, it can go quicker. I know it doesn't seem like a quick process. So make sure you're doing the homework, going on to our chat sessions and asking questions if you need help, posting to the discussion board if you have specific questions that I can try to answer.